Hello everyone, in this video I'm going to discuss the topic differentiation. Here we have the derivative of a function. F prime x is equals to limit when h approaching 0 for the function f bracket x plus h bracket minus the function fx over h. F is said to be differentiable or has a derivative if f prime x exists. So here are the example. Given that y is equals to square root of x, by using the first principle, find the f prime x. So given the formula for the first derivative, or by using the first principle, we have f prime x is equals to limits when h approaching 0 for the function f bracket x plus h minus fx over h. So now we are going to use the formula to show that or to find the f prime x. So f prime x is equals to limits when h approaching 0. For the function x plus h, we're going to sub x plus h into the function square root of x. So where we will have square root of x plus h minus square root of x over h. Next, we are going to sub the value. So now the h is equals to 0. So we have square root of x minus with the square root of x. And we will obtain 0 for the numerator. And for the denominator, if we substitute the 0, and we will obtain 0 for the denominator. So here we have an indeterminate form. There are several strategies that we can use to solve this kind of situation. Number 1, multiply by the conjugate. Number 2, factorizing the situation. So for this case, I'm going to multiply by the conjugate. So f prime x is equals to limits h approaching 0 square root of x plus h minus square root of x over h. Next, I'm going to multiply the conjugate. So the conjugate would be square root of x plus h plus square root of x over square root of x plus h plus square root of x. Next, I'm going to expand the situation. I'm going to expand only the part of numerator. So f prime x is equals to limits when h approaching 0. If we expand, we will have x plus h plus with square root of x plus h minus square root of x plus h minus the x over h bracket square root of x plus h plus with the square root of x. Next, what we're going to do is to simplify the situation, and we have x minus x. We obtain 0, and we can simplify the situation and become 0. So finally, we have f prime x is equals to limits when h approaching 0, h for the numerator over h bracket square root of x plus h plus square root of x. After we simplify, we will have limits when h approaching 0, 1 over square root of x plus h plus with the square root of x. So finally, after we substitute the situation, meaning that 0 into the function h, and we will obtain f prime x equals to 1 over square root of x plus square root of x. So finally, f prime x will be equals to 1 over 2 square root of x. So here we are, and thanks for watching.